Look, if you've been building AI agents lately, you are probably exhausted. Truly, deeply exhausted. And honestly, I don't blame you. Orchestrating multi-turn, long-horizon workflows today basically means paying this massive, painful context processing tax. Every single turn, every tool call, you're packing up the entire history of the conversation and just shipping it back to the model over and over again. It is incredibly inefficient. But that era is finally ending. Welcome to this explainer, where we are going to break down exactly how the Google Gemini Interactions API is completely re-engineering how we build autonomous systems. Okay, let's dive right into this.
Here is our game plan for today. First, the context processing tax. 2, enter the Interactions API. 3, the unified steps schema. 4, managed agents and sandboxes. 5, enterprise governance. And finally, 6, your migration roadmap.
All right, part 1, the context processing tax, and really, the true cost of statelessness. To really understand the solution here, we have to understand why orchestrating workflows right now feels like you're constantly fighting the infrastructure. I want you to think about your current applications for a second. Why are your AI workflows lagging so much? And why are the costs just skyrocketing the longer a conversation goes on? Well, the blame lies squarely on the heavy burden of client-side stateless orchestration. Your app is doing all the heavy lifting of just trying to remember what literally just happened. Think about the legacy generate content API like an amnesiac coworker. Every single time you speak to them, they forget absolutely everything you've ever discussed. You're forced to recount the entire history of the project before you can even ask your next question. That stateless approach scales quadratically in both latency and token consumption. The new stateful paradigm, on the other hand, actually remembers the project. It shifts all that state preservation straight onto the server. Which brings us nicely to section 2. Enter the Interactions API, the stateful foundation. This new API is the foundation that completely replaces that amnesiac architecture we were just talking about. And the hero mechanism here? It's literally just a simple parameter called previous_interaction ID. That's it. When you send your next prompt, you pass this ID, and Google automatically retrieves the historical context server-side. The economic impact of this implicit caching is absolutely massive. I mean, look at the context cache base price for Gemini 3.5 Flash. It drops all the way down to a fraction of a cent per million tokens. By keeping that historical context warm on Google's high-performance memory infrastructure, you drastically slash your token budget and your processing latency. Now, you might be wondering, just how long does that memory last? Well, for paid enterprise tiers, the Interactions API retains those stateful interaction resources for a massive 55 days. 55 days! That means your agents now have true, long-term memory without you ever having to pay those painful network rebroadcasting penalties again. Let's move to section 3, the unified steps schema, because it's time for some transparent execution. So solving the memory problem is really just the first half of the equation, right? We also need to see what the model is actually doing behind the scenes. Under the old legacy system, models outputted flat text, which made it practically impossible to debug complex multi-step reasoning loops. It was a total black box. But the new general availability release abandons that entirely. Execution phases are now discrete, strongly typed steps within an array. You have your user input, then intermediate events like a thought step, and get this, the thought step actually contains a cryptographic signature to verify the integrity of the model's reasoning, before finally reaching the model output. Developers, you finally have your visibility back. And to make this even better, server-sent events, or SSE, map perfectly to this new schema. Instead of just sitting there listening to generic blocks of text streaming in, your app can now subscribe to specific step lifecycle events. So when step.start fires for a thought step, you can dynamically render a cool little loading spinner in your UI. Or if a code_execution_call starts, you can pop open a custom code console for the user. It just makes building interactive applications so much cleaner. All right, section 4, managed agents and sandboxes. Let's talk environments. We are moving out of the API mechanics now and into the playground, because once an agent decides it needs to, say, write some code or search a file, you need a highly secure place for it to actually do that. Historically, this meant you had to build and maintain your own crazy, complex orchestration frameworks. But Google has introduced a fully managed runtime environment called the Anti-Gravity Agent Harness, and it is a real game changer. It can plan, install packages, compile code, run bash commands, manage file systems, the whole shebang. And let's be totally honest here. We can all appreciate the immense relief of never having to maintain our own fragile, constantly breaking Python sandboxes ever again. And this all builds into an incredibly efficient lifecycle. These isolated Linux containers aren't just single-use throwaways. They persist. When your agent is idle for 15 minutes, the platform takes a snapshot of the container's file system. It goes offline, retaining that exact state securely for up to 7 days. By just referencing the environment ID later, you can resume your workflow with all your installed packages and shell variables completely intact. So that dreaded cold start delay, yeah, it's completely eliminated. Okay, Section 5, Enterprise Governance and Omni. Time to talk security. Because look, deploying cool sandboxes is great for a weekend prototype, but to satisfy enterprise decision makers, we absolutely have to talk about strict security. Scaling autonomous systems requires robust governance. So instead of using broad, honestly kind of dangerous service accounts, the Interactions API introduces spiffy formatted agent identities. This is the essential security mechanism replacing those old accounts, allowing security admins to grant highly precise, least privilege permissions directly to a specific agent. This is exactly how agents like the always-on Gemini Spark can operate safely 24/7 in the background while still adhering to strict enterprise policies. Furthermore, all of this is protected by a secure agent gateway. You can think of this as a header transformation proxy combined directly with Model Armor policies. It intercepts outbound traffic from your agent's sandbox and safely injects your authorization headers server-side. The massive takeaway here is that even if a malicious script somehow runs inside your sandbox, your actual API keys and credentials are never, ever exposed to the file system. They simply cannot be stolen. On the model capability front, we have the new thinking level parameter, introduced with Gemini 3.5. This lets you strategically match the internal reasoning power of the model against your specific token budget. You can dial it to low for super fast code reviews, keep it at medium for standard reasoning, or crank it all the way up to high for complex architecture planning and advanced math. It puts the control in your hands. And running on this data plane is Google's flagship generation engine, Gemini Omni. Unlike older models that have to clumsily convert video or audio into text descriptions first, Gemini Omni processes all media natively within a single transformer. It can perform multi-turn conversational video edits, simulate physical gravity and lighting, and crucially, all generated videos are automatically embedded with an imperceptible Synth ID digital watermark to absolutely guarantee authenticity. Which brings us to our final section, Section 6, Your Migration Roadmap. Let's bring this explainer to its practical conclusion. What is the exact sequence of actions your engineering team actually needs to take to modernize your applications right now? Well, the absolutely crucial first step is getting your SDKs in order. You must update to the Google Gemini Python package version 1.55.0 or later, or the JavaScript equivalent version 1.33.0 or later. Now, keeping it totally real with you, there are a couple of limitations you should be aware of during this migration. Right now, batch processing is not available for stateful interactions, video metadata clipping isn't fully supported quite yet, and automatic Python function calling does require some manual execution loops for the time being.
But honestly, the path forward is incredibly clear. Step 1, adopt stateful sessions by implementing that previous interaction ID we talked about to leverage implicit caching. Step 2, migrate to the Steps Schema by refactoring your parsing logic to handle the new typed array instead of that old flat text. And Step 3, establish secure workspaces by deploying your isolated environments using declarative agents.md and skills.md configurations.
Which leaves us with one final provocative question for you to chew on. Are you ready to let go of the orchestration wheel? The days of fighting client-side complexity, managing bloated context windows, and building your own fragile sandboxes are officially over. It is time to embrace the fully managed, stateful future of AI architecture. Thank you so much for joining me for this explainer, and I will catch you in the next one.